All right, so we are at the top of the hour, so we're going to go ahead and get started. So good morning. Hi, everyone. My name is Kim Schofield. Thanks for taking the time to join us for this month's Detect to Protect webinar. I'll be hosting the webinar this morning, introducing our panel and also going over a few housekeeping items. So first of all, as a reminder, our webinar is being recorded this morning, and a link to the webinar, as well as a copy of the slides and some other supporting materials will be emailed out to you shortly after the webinar. Second, if you are attending on today's call, we are planning to send you a free copy of our book, The Security Guides, Analysts to Suricata. I'll talk a little bit more about that, provide some more details about that at the end of the presentation. And lastly, we're going to be discussing 6 different tools during the webinar. So we're going to pause when we finish each section to give folks an opportunity to ask questions. So we would ask that you please type those into the Q&A section of your Zoom window. All right, so to get started, Mark, if you want to go on to the next slide there, I just wanted to take a few minutes to introduce everyone to Stamus Networks. If you're not familiar with us, we are a global provider of high-performance network-based threat detection and response systems. So our flagship product, the Stamus Security Platform, combines the best of IDS, NSM, and NDR into a single solution. And that gathers insights from the cloud and on-prem network activity to help expose any unauthorized activity and threats on the network. So our team has actually been working with Suricata since its inception, and we have applied the expertise that we've learned to optimize our solution, which actually is built on top of Suricata. So we do have many members of our team that are actively involved with the coding, QA, and management of the Suricata project. So that makes Stamus Networks a major contributor to Suricata, really more than any other commercial organization in the world. So if you want some more information about Stamus, you can visit us on our website. All right, so let's go ahead and introduce our presenters today. So we have Matt Jonkman with us. He's going to be moderating the panel, and he is the co-founder of the OISF. That is the governing body for Suricata. And he brings over 15 years of security and entrepreneurial experience to the foundation. Matt was also the founder of Emerging Threats, which is now Proofpoint. That's the developer of the leading Suricata rule set. So Matt is joined by our panelists, Peter Manev, Eric LeBlanc, and Marcus Kant, and each of whom have developed the solutions that we're going to be talking about this morning. So Peter and Eric are the co-founders of Stamus Networks. Peter is our CSO. He's an active OISF member and has been for a decade, and he has over 15 years of experience in IT security. And he's also the lead developer of Selks, which we'll be talking about this morning. Eric is the CTO and an active member of the security and open source communities. He was a NetFilter core team member, and he also works on the development of Suricata. He's actually one of the core developers of the product. And lastly, Marcus is our threat researcher and software engineer. Before joining Stamus, he spent over 5 years as a researcher in the NATO Cooperative Cyber Defense Center for Excellence. So with that, I'm going to go ahead and turn the mic over to Matt and let him get started.
Thanks, Kim. Good morning, everybody. It's a pleasure to be here. I've been retired for a little while and kind of out of the community and watching, and it's nice to come back and see everybody again for a moment. The projects we have that Stamus has lined up to talk about today are wonderful, and they're all definitely key projects that you should be aware of if you're doing just about anything around Suricata. At least 2 or 3 of these are going to be applicable likely to your daily life and how you're doing things. So I think it was a good choice to come in to listen to these and keep an open mind with these projects, because I think you'll like what they're doing. So with that, why don't we jump into the very first project, which is Peter Manev and Selks, the project overall with Stamus. That's really been one of the projects that Peter will probably talk a little more about this, but Stamus, I think, really evolved out of Selks, and it's proving to have been a good tool, and it's proving to be a great tool for the community. Selks on its own, even without any commercial things around it, that just having that to where the average Joe can put up a quick and very effective monitoring platform for nothing has been a great thing for our community. So with that, Peter Manev.
Thank you very much, Matt. Thank you very much, Kim, as well. Pleasure to be here. Well, basically, Selks, in a nutshell, we started it around 2014, 2015. Basically, out of there was one real reason to start it, and that was to showcase what Suricata can do on the network. Anything and everything from not just to the traditional alerts, but also other network forensic evidence that Suricata produces, including protocol logs, extraction, PCAP, and so on and so forth. So Suricata kept evolving with time, and this is one of the main reasons it kept us going as well. So Selks is basically an open source turnkey Suricata IDS, IPS, NSM threat hunting implementation. It's available on an ISO or as a Docker Compose. It could be spin up on pretty much most Linux distributions out of the box, like Ubuntu, CentOS, Fedora, things like that. You just spin up a Docker Compose there, and it's ready to go. It includes other open source tools inside there, so it's not it's like a bundle. So it's not just Suricata, but it has, for example, specific. It's composed by open source tools specifically developed by Stamus, for example, Sirius for threat hunting and rule set management, but others as well, like Evebox, developed by Jason Ish, who is one of the core Suricata team members and part of the exec council, and the Elk Stack, Kibana. We also have Arkima in there and so forth. So basically, a showcase any and all data produced in there is produced by Suricata. So basically, a showcase of what you can do with Suricata, and it kept evolving. So one of the major reasons that it kept evolving is the community. It's open source. It is also a very big help that we receive from the community all the time. On Selks, that includes feedback, that includes criticism, that includes what's working, what's not working, features, code donation, similar things, including now we have some of the code donation that we have is around Kubernetes. It's on GitHub public, of course, and all those sorts of things. We actually have around 240 forks on GitHub and close to 1,000 stars on GitHub, which is very, very thankful for the community around it and for keep using it, and which actually gives us some feedback that is actually useful and people find it useful. Alongside with that, also the community has helped us develop around 28 ready-to-use dashboards for audit, network security monitoring, threat hunting, based on top of 400 different visualizations out of all the different types of data that Suricata produces. Again, it's a showcase for Suricata, and we hope we can keep it going with the community help, and of course with the open source tools that are comprising it. Yeah, I'm really struggling to condense myself inside the timeline here, but I'll transfer it back over. Thank you very much.
Thanks, Peter. And my apologies. I jumped into these really quick because I'm eager to hear these guys talk.
There's no problem.
But we're trying to keep this to about 3 minutes. They're going to talk about each project. And if you hit the Q&A button on the bottom, type in any questions you've got, whatever, for any of the projects as we go through. And after each one, I'll try and take some of the good questions there that will inform everybody and ask those for you. So while you're talking, while you're listening, throw those questions into Q&A. We will get them going. But so if you have any right now for Peter, please throw them in right now. I have plenty. As you know, as I mentioned, I've been a Selks user for years as well. And it's very stable. It's been good for a long time. Peter, what are you guys looking at for the new? Are there any new big features coming up? Is there a change coming, or are you in stable and works really well for a while right now?
Okay, yes and yes, both and both. So actually there is new features coming, and that's one thing about Selks is always runs the latest actually Suricata. Thanks also that for our help. Big shout out to Jason Ish, who supports the Suricata Docker for us on the Dockerized version. So that's one thing about showcasing what Suricata can do. It runs the latest Suricata with the latest features in there, but we are introducing actually more features upcoming in the next couple of months, most likely, especially around threat hunting, a little bit around specific stateful threat hunting, if you will, with the help of Jupyter playbooks and similar. And I'll let my colleague Marcus talk a little bit more about that. But yeah, there is, alongside those nodes, there's many improvements and things coming up, including in threat hunting and including in detection capabilities and all that. All open source, of course.
Great. Thanks, Peter. And what is the overall the license for Silks? Can you call it GPL v3 top to bottom, or how does that stand with projects?
Yeah, absolutely. GPL v3, open source on GitHub. Yes.
Okay, great. Question from the audience. And this is a little bit of an odd question, but I think it's good to answer. Will Silks run on Security Onion?
I've never tested it. I've never tried it, but I see no reason why not. So it's basically a Docker Compose app. But again, you might want to see what exactly you want to test out, or which components would be useful to you.
Thank you, sir. And to reiterate the licensing thing there, my history in Suricata, I was never the coder. I didn't put a line of code into it, and that's why it works so well. I was the administrative, getting us funding and get us managing our licensing stuff. And the fact that all these projects you're going to see today are all GPL v3 top to bottom is a very important thing, because we did have in the early days of Suricata pretty significant legal problems that we had to avoid and make some major changes because of our initial licensing and future licensing and what GPL v2 and 3 did. So it is important. And for those of you that are looking for any commercial application of these projects or use, or even just within work or within products, GPL v3 covers you very well, and it covers the authors very well. So we're happy that all these projects are v3. So do we have any other questions right now for Silks? And if you do, and if you don't get it in before we move on here, we will try and swing back to any important questions as well. So next, why don't we move on to the Stamus network app for Splunk, which if you're a Splunk user, you will absolutely love this. It's another one of the great free products that Stamus makes available, granted related to their product, but it is a very valuable thing if you're a Splunk user. So with that, Eric, would you fill us in? And again, type your questions in while he's talking. We'll get them answered after he's done.
Hello, everyone. So I did start the Stamus Networks app for Splunk because the Splunk query language is super powerful, but in a lot of cases, when you say super powerful, it means super complicated. So we had a combination of fact that people were using Splunk to see some Suricata data, but in fact, you need to know in this case what Suricata data you have and what you can query with a Splunk language, the Splunk query language, sorry. So it was a combination that was a bit complicated. So we did decide to work on an application for Splunk that will handle the Suricata data. It also has some extension for Stamus product, but almost everything is also done for pure Suricata data. So the concept is to provide some ready-to-use dashboard that you can use to see what is happening on your network. And at the same time, you can also use that as an example for query you can do that will be adapted to your infrastructure or your organization. So we really hope that this application that seems to be quite used is helping people to understand that Suricata is not just an IDS, it's also a network security monitoring tool that generates transaction log. For example, I'm a little French troller, so we got the Suricata for Zik user. That is a dashboard where we did implement a lot of network security monitoring query that showcase all the transaction log, so HTTP, TLS, DNS, SMB, and the other one that you can have with Suricata. As the other tool, it is open source, and it's available on Splunk base, so you can directly install it from your Splunk instance.
Interesting. Thanks, Eric. So what is this project? Is it is it stable? Are there things coming still? A similar question to what we asked Peter. Are there new things coming, or is this stable and ready for production for long term?
So on this one, I think it's kind of stable. We did implement what we really want. We did do release 1.0 some month ago. And after, I think the development has been starting something like 1 year or 2 years ago. And we don't have bugs open, so it should be fine. Joking. But yeah, so now it works. We got almost all the data. I think we will need to add a few more dashboard because we follow the Suricata version. And as the new Suricata version, Suricata 7, is going to have some new protocol support, we will need to add some new dashboard. But basically, it's maintenance, and the rest is already there.
Speaking of that, as Suricata is changing, do you see any points where this and other data brokers that are taking data out of Suricata and putting them to Splunk or other databases, is there anything coming in the Suricata schema or the output that's going to maybe break this app and some others that we need to watch for?
I don't think so currently, because it is using the JSON format, which is the standard that is parsed correctly. And the Suricata development team is taking care of maintaining backward compatibility on the event. So they stay the same, but they will add some more feeds inside. So as it is mostly addition, maybe it will not be parsed or not used as good as it can by the solution, but at least it will not break the solution.
Great. It reminds me of the days when we converted to JSON for Suricata output. I remember how painful that was and how much coding, especially you and others, did to convert our output to JSON. But I think this is another one of those instances where we're reaping the benefits of that work we did years ago. Any output can be ingested into about anything, and we don't have to make major changes. I hope.
Yeah, for me, it's really a key point in Suricata. One of the things I really like is the fact that in Suricata alert, in Suricata IDS event, you have all the protocol metadata inside. So in one single event, you already knows what it is about. You don't need to spawn Wireshark or anything on a PCAP that it capture elsewhere to try to understand what is the protocol or do complex correlation with some other event. Everything is already in the alert in 99% of the case.
Overall, what do you think was the biggest challenge in creating this app? 'Cause I mean, it's single purpose. It seems like it might be simple, but I'm assuming it was not simple. What were your biggest challenges in making this?
Sometimes I think I'm not a super advanced Splunk user. It's not my daily job. So one of the things that was complex was to do some advanced query in Splunk language to be able to extract the data I want, because there is some fancy, complex stuff inside some of the dashboard. So here I struggle a lot to build the query.
Thank you. Well, it's definitely a valuable thing, a great project, and it's very valuable to have out there. So thank you, Eric, for your time here. And again, if you have a question that comes up of any of our previous talks, feel free to throw it into the Q&A. We'll try and fit those in as well. Next up, we have Marcus Kant with Jupyter Playbooks for Suricata, which is this one I'm not super familiar with myself. I haven't jumped into the Jupyter stuff, so I'm very, very interested in Marcus's talk. So please, Marcus.
Hello. So, actually, good evening from my side, because I'm in Estonia and it's not morning in here. So if Selks is where Stamus was coming from, then I would like to think that the playbooks is kind of where we're going towards. And I'm going to preface everything I'm going to say by saying that I did a talk at Suricata. It's out on the YouTube video, and I'm also writing a fairly lengthy blog series about the topic because there's a lot of ground to cover, but I will try and do my best to keep it within the time. So what is a Jupyter notebook? It is a interactive coding environment. It's organized into cells, and you can have code cells and markdown cells. So you can write any code, primarily in Python, but other languages are supported into the code cell. You can execute it and it gives you instant response. Like you see the output. This is used by data scientists to do fast prototyping and research. And I've been using them as basically one of my primary tools as a researcher here in Stamus to explore Eve, because Eve has a lot of data, too much data. People don't even know how much data there is. So, the data science communities have very good tooling to actually make this, actually expose more of that data to the user. A lot of threat hunting in Suricata is still alert-based. But again, like from my background, I actually like digging into the raw data, like the protocol logs. I actually come from using Archive, full packet capture. So I just like going into raw TLS SNIs, writing queries, this kind of stuff. And, you know, in Selks, we have Kibana, but Kibana is a generic tool. It is meant to handle every kind of data. So it doesn't really handle any specific kind of data, like as well as a purpose-built tool can. So I started this project as a way of extending what we do around Selks and our commercial platform. So the hardest part about making these notebooks is actually ingesting the data, because it's easy to make a notebook that you can never reuse. So what we are doing now is like our product already uses REST API endpoints. I added a couple of more that I felt were missing, like a very simple one. Give me all unique fields, show me all unique TLS SNIs for that query. For example, like show me all unique TLS server names going from the inside network to the outside, and give me just a stupid list so I can find stuff like Microsoft.com, Amazon AWS, Mozilla with 3 Ls, this kind of stuff. This project includes a data connector library to be able to easily just start the session to the either Selks or SES. You can see the word serious there. That's because it's actually generic. The API endpoints and connector is open source. You can use it the same way on the open source stuff as you can with the commercial products. And as I said, I think my time is already up. As I said, I have about 3 posts already out. It's a nice, cool little picture that Mark was nice enough to put there was actually from my last one, where I showed how to make Jupyter, how to basically apply simple data mining methods like k-means clustering, principal component analysis, this kind of stuff on top of Suricata data, how to like actually process the data, how to like prepare it, how to apply it, and what kind of insights can be found. And with that, I will pass it on.
Interesting. Thank you, Marcus. That's fascinating. So do you see this as a tool for the individual researcher to keep their notes on one particular thing they're investigating, or do you see it as kind of that investigation ticket that would be stored, for the actual investigation documentation?
So the cool thing here is that with a notebook, like either options are fine, because you can be I actually wrote my blog series in a notebook and then converted it into a blog, so people can actually open, and that notebook is up on that repo. People can actually go and interact with my blog post, for example. Reporting is something that we are very interested in looking at here in Stamus currently. But actually, there's also one notebook in the repo that allows the user to do fully interactive hunting on any Eve data using some widgeted codes. So you can basically apply a Kibana query, lift it from Kibana if you're familiar with it, put it into a text box, and then say, okay, show me those columns, those fields. Like I really like row column view of stuff. aggregate based on either unique flow IDs, unique server, like source IPs, destination IPs, host names, this kind of stuff. Just show me unique values, show me unique source IPs connected to destination IPs, and draw a nice graph. Show me who is talking to who, this kind of stuff. So that's, it's a vague answer, but the possibilities here are actually endless, because you can it basically gives you access to the data. The next question is like, what do you actually want to do with it? And I hope the project, I hope the project will package enough useful notebooks that people can already use, but also spark some ideas how they might want to use it for themselves.
That is fascinating. The ideas are swirling in my head on the things you could do with this. I personally, I know I need to learn a lot more about the playbook concept.
I would like to point out actually something I forgot to mention. This data connector library is very much inspired by what the Microsoft Threat Intel guys are doing in the Mystic team. They are organizing this online event called InfoSec Jupyter Fun, where people actually talk about this. So for anyone interested, I highly recommend checking it out. They also have a very cool Python library called Mystic Py that packages all sorts of useful visualization tools like timelines. They even have like some pre-built machine learning stuff you can apply, threat intel queries, this kind of stuff. So I highly recommend checking that out as well. What I'm doing is very much inspired by what I saw those guys were doing already.
Interesting. So do you see this? This is a very abstract question, and I don't mean to be jumping on the AI bandwagon that's going to solve our problems, but do you see this? Is this a mechanism where some type of more sophisticated AI processing, this could be a conduit for that to dip into the database and give that back to us in a way we can understand it in a playbook instead of something raw?
Yes, exactly. I mean, the last blog series was kind of aimed at showing things like that. The thing about AI is that, well, I don't really want to get into that topic here. We definitely don't have time for it. But I think of AI and data mining. Like, I don't want to use the AI and machine learning. Let's just say data mining. So data mining, I think of it as just another detection method. It works differently. It applies to different kinds of problems than regular rules. So, for example, like I don't know what threshold I should use. So let's try to get like a normalized measurement and just say, show me everything below this abstract measure 0.1, or for example, or again, stuff like trying to find beacons, find connections where, you have like very flat connection timings between different flow records, things like that. And actually, yeah, the playbooks are literally built to bring this kind of. It is very much for the advanced users. Making this digestible to maybe newcomers is a very difficult task. But if you already understand some key concepts, then it's very easy to actually like ingest some data, try out some methods, see how they actually work. It might give you some useful insights into the data, or in general, you might just understand a little bit better what all of those AI vendors are actually like trying to sell you.
Yeah, I think all of us need to understand better what the AI vendors are trying to sell us, but that's a whole different talk. So you mentioned it might be difficult for the new user to jump into this. Do you mean just new to playbooks or new to Suricata? Which would both have trouble with this?
So probably, well, new to playbooks. There are different kinds of like in the blog series, I try to like connect, different. So if you're already familiar with Suricata, then there will be a little bit of a learning curve trying to understand, how the data science tooling. Again, it's like prepared notebooks are going to be help here. There's like idea is to also package some hunting stuff into notebooks as well. But in general, like it's just you will need to read some code. You might need to write some code yourself. And it's a little bit tricky in the sense that even if you are an experienced coder, data science libraries work a little bit differently than what you're used to normally. Forget about for loops. And welcome to the fun little functional world of applying stuff on top of basically you have to start thinking about matrices, vectors, numbers, and this can be a very steep jump at first. But I would like to say that, once you're over the initial cliff, then it does actually get better.
So it's a fascinating project. So it sounds like it'd be a really good where you pop in and get your daily reports. Here's what I need to chase down today.
Yes.
Sounds like that'd be one. All right.
Yeah, as I mentioned, that's something we're interested in actually exploring for what we're doing on the commercial side. And, of course, open source as well. The notebooks that we push out are all open source. Many of them, are stuff that we've been tinkering behind the scenes, but, that don't really have the time to build out a feature. So a notebook is actually a very cool way of just giving it out to the people, getting some feedback, seeing how it actually works, and then maybe committing into building some kind of a feature into product, right? So it's a tool for us as well in that sense.
Awesome. Well, thank you for doing this. Thank you for applying. I'm always really interested when we take a new thing that's outside of our sphere and apply it to what we're doing, and that always ends up as a net gain for everybody. So thanks for doing this. I am definitely going to jump into it and learn something about it myself. So let's move on to our next lateral movement rule set with Peter Manev. You heard Peter speak earlier. Of course, he's one of the greats of Suricata, and this rule set is one that rule sets like this have been around for a long time, but I know from my old days when we were writing the rule sets and pushing them out, it's very, very misunderstood. A large majority of the support calls we used to have in the early emerging threats days were just people misusing that lateral movement rule set, trying to apply it in the wrong network segments, things like that. So I'm very interested to hear where Peter's got this right now. So Peter.
Thanks, Matt. So actually, I'm going to try to give a little bit of a background history as well. Again, this rule set is open source. Basically, Suricata is community driven. Suricata is open source, right? And when you're driven by community, usually the greatest part about it is that the community is able to feed back or give back. And that's what we're doing, and that's what we want to do and continue on doing. Mainly, Suricata keeps evolving, and that keeps us evolving with Suricata in everything we can do, especially in terms of detecting bad actors. Now, the idea of this rule set basically was enabled by certain features and fixes that came available in Suricata, as I said. We were actually, at Stamus, we participate in different cyber exercises with Red Team, Purple Team, so on and so forth, some with customers, some with organizations. This rule set was actually came out of active testing and us trying to find out the Red Team at and hunting for Red Team's activities at Locked Shields, which is the largest NATO live fire cyber exercise. There basically, this rule set is concentrated on SMB DCRPC, lateral movement in Windows environments. So what it does is highlight certain activities, okay? So it's not like true positive or false positive. It just highlights, it says this happened. Now, for example, what does this happen means? It means the things that it highlights are somebody scheduling a remote task. Somebody opening remotely the registry of a computer or a server, somebody creating a service remotely, changing a printer driver, creating a network share, resetting a password remotely, just doing it via traditional SMB DCRPC way over Windows. Now, that by itself is just, as long as it goes, it says this did happen. It doesn't say it's a bad thing or it's a good thing, because it doesn't matter. If somebody schedules a remote task, does a scheduled task remotely, it doesn't necessarily mean it's bad. It could be just the IT admin doing it. Now, here's when the hunting part comes in. So usually in an organization, you would expect that to happen from certain users or from certain areas of the network. You wouldn't expect it to see from an area, let's say, sales or users or Wi-Fi networks, guest networks, and similar things like that. And that's where the hunting part triggers in. You have some knowledge of your environment when you employ this rule set to actually highlight events like that. So there it becomes very useful, and we've actually used it with a great success as one part of the many detection mechanisms that we have. And I spoke to Erga then. It's like, look, we just need to open source and give it back, because this is actually could be useful to other folks as well. And that's what we did. This is actually the background and how this donation came back. And again, we didn't have something similar like that before. It was basically a community-driven effort, and by us being part of the Suricata community, and we said, okay, this is some part where actually Suricata or Suricata users and community could actually use it, because there was nothing like that ever before. So it's strictly based on actions and events occurring in Microsoft, as defined by Microsoft protocols in different SMB setups and environments. Very, very useful, at least in our case, as I mentioned, for hunting down the red team, and including tools, red team specific tools, uses like Sharphound, Bloodhound, and so on and so forth. I did actually a presentation at Suricon about that last Suricon in Athens 2022, and the YouTube video is actually public of what's possible to do. And open to any more questions, or back to you, Matt.
Thank you, sir. Yeah, and I reiterate that if you have any questions, this is your chance, because there are a ton of very specific things in the lateral movement rule set that we couldn't possibly jump into and even touch on all of them. But if there's something that's burning or something that's been a problem for you lately, it's a very good time to ask. So, Peter, overall, what when applying a lateral movement rule set, even like the ones that we have that are on the open source side, like this one here that you're curating, what would you recommend as the general tuning process when you apply something like this, and what network should it be on and not be on?
Very good question. Thank you. So again, this specific rule set is actually, I wouldn't even call it for alerting. This highlights certain activities in SMB DCRPC. So in other words, imagine you have 100 million SMB events a day, which is not unusual for Windows networks. It's very, very usual, actually, even more. So out of these, you want to know, okay, how many of these events actually refer to scheduling something remotely or creating a service remotely. And that's what this rule set gives you. It just says, okay, out of these 100 million events, you have these 500 or 100 that are in there. Now from there, you're going to go crunch it down, because this is actually a rule set is meant to be more generic so everybody could use it. But each setup is different. Each organizational setup is different, or Defender's network is actually different, right? So you probably know best where your servers are. You probably know best where your end clients are. You have the different networks, the IPs, and which areas they come from. So then actually what you're looking for is, okay, who scheduled or who attempted to try to schedule a remote task or create a service or open likely the registry remotely of a server, but it's not part of the IT admin network. That's an interesting activity, actually. That's something that you're going to come after and most likely try to investigate, because basically this is the whole idea. Threat hunting comes out of experience or something you knew, a hypothesis that you have given the local network or the local organizational knowledge that you have. So based on that, you employ other tools to highlight a specific event that will be of interest to you. And then based on all the network and protocol related data, you can actually, with the Suricata logs, for every specific event is related to another in the same flow via something called flow ID. Suricata has natively that since, if I'm not mistaken, 2014. So based on that, you actually have all your network evidence in there, protocol evidence of, for example, who logged in or who did that activity, or what PC did the activity, or where it was done from. And then you can determine pretty quickly, it's like, okay, this is something I need to raise an alarm note or not. And that's actually a capability to crunch down all these, let's say, 100 million events into like the 5 that you might want to look at today. And of course, you need to employ some sort of automation around this and all that. But that's where it helps. That's where it helped us anyway in the red team exercises.
Okay. So I'm hearing you want to be very careful and deliberate about where you apply this, but it's going to be a lot of data, and it's going to be kind of your network flight recorder, like an aircraft flight recorder, your network flight recorder. It's just going to have all that back. So when something pops up, you're going to have more than just your server logs. You're going to have a lot more data. Is that the gist kind of, or the use of this rule set?
Yeah, it will crunch down. It will actually crunch down out of, for example, as we're giving the example, out of all the SMB events, it will crunch down, for example, specific actions or things that were done. And then out of these, you'll take out what you need. But the crunching is about 80-90% of the total SMB data. So that's where it actually comes out useful, because on the network, you can actually observe a lot in Windows SMB environment. Of course, you have the endpoint logs and all those sorts of things, but that's a separate issue. But here in the exercise that we're involved with, we're actually looking at the network. So we need somehow to make sense out of these million events and be like, okay, what are instead of looking at 1 million, can we actually employ something else that will highlight activities that we're interested in, and crunch them down to 5, let's say. That's where this rule set actually comes in, helping out with.
Okay. So I understand you guys were involved in the Lock Shields exercise this year. If you're comfortable, could you say, was this rule set used there, and was it useful in that kind of an attack defense scenario?
We're not allowed to disclose much, to be very honest, just because of the environment that we're participating in. However, our team did finish second. And this was actually, again, this was one part of all the detection that we employ. Marcus also talked about Jupyter playbooks. We employed that with also great success. The rule set here actually helped us actually as being basically on the network, the only thing that highlights actually a possible lateral movement from red team. Now, the red team in the exercise, they were actually very aggressive. I think in the exercise during the first 15 minutes, they attempted domain control takeover. So things like that, they usually highlighted also on the network and similar things. So it's an essential part of the whole step of different detection methods that we have. But I cannot imagine having an exercise, or me personally participating on the security monitoring of that exercise without this tool set, because it highlights certain type of events that I want to know about. So when it's employed, I know it's there, and I know if something pops up, I need to act on it and think on it. So that's after, of course, setting it up correctly with the correct variables and knowing a little bit about the environment. So I cannot imagine that exercise without me participating in the exercise without this rule set. It's not the only thing, but it's one of the many things that we employ.
Interesting. I like that. Question from the audience here. Is this in the ET Open feed, or essentially how do I get these rules, and when are they updated, that kind of thing?
Oh, actually, it's on the slide, on the bottom link. On the bottom of the slide, there is a link of how exactly to get it. It's not part of the ET Open. It's just open source and released to anybody that wants to use it. Again, GPL version is just hosted on our Stamus Threat Intel hosting platform.
Great. Well, last call for any questions for Peter there, and we have one more chat to do. The Suricata language server, which I don't know how you could say which of these projects is maybe, or no, sorry, we have 2 more. I don't know if you could say which of these projects is more complex, but the Suricata language server is definitely up there on the scale of complexity, just because of all the interactions that the language can do and performance and things like that. So again, if you have questions about any of the previous talks, throw them in there. We will work them in as we can. And if you have questions about the upcoming talk here, throw them in there while Eric's talking, and we'll get them answered as soon as we can. So with that, Eric LeBlanc, please tell us about the language server.
Okay, so just before I told you I'm French, so I'm a little troll, but I'm French, which means also that I'm lazy. So what does it mean by lazy? I'm teaching Suricata from time to time. If you are teaching Suricata, you need to teach your student how to write signature. Writing signature is not easy. You've got more than 100 keywords. You never know which one to pick. You never know if it's an underscore, if you got an HTTP prefix or not, if you are working on some HTTP signature. And once you wrote the signature, the only thing that you can do before the Suricata language server was just to say, okay, I'm going to test this signature. So you spawn your Suricata in the command line, give it your signature file to read, and try to see what error you get from Suricata. So this is painful. And Suricata also offers some really interesting tool that give you performance hint, which is the engine analysis. It's a command line flag by Suricata that gives you information about the correctness and the performance of the rule. And it's another command you need to run every time you are trying your signature. So that was really too slow, not easy. So I did decide to implement a language server protocol. So the language server protocol is JSON RPC protocol developed by Microsoft to use in Visual Studio Code, but that has been picked up by everybody because it's an open standard. And it allows an editor to speak with a language server that is implementing syntax checking, auto-completion on any tips of things like that for a specific language. So if you develop one language server, it can work with all the editors that support the language server protocol. So that's what I did with Suricata. I did not re-implement all the features done by Suricata inside the Python code that is a Suricata language server, but I did choose to use the Suricata install on the box you are using to edit your signature, so that you have exactly what Suricata will output that will be used in your editor. So there is no emulation, it's just getting the information from Suricata, and it will give you, if you're running Suricata 6 in your instance, or you're running Suricata 5, you may have different output, but it will correspond to what you have in production. So that's really interesting. So it's currently supported by almost all the language. We did test, some editors to set on the setup is written on the web page on GitHub. So you can set it up with Kate, NeoVim, Sublime Text on Visual Studio. It's you got a configuration sample, so you can use it directly on this editor. But it should be supported on any editor that is supporting the language server protocol.
Awesome. Thank you, Eric. I have questions, lots of them, just because this is you're coming from writing rules for most of my career. I wish it existed for most of my career, because and anyone writing rules spends so much time tweaking their rules, get the syntax right. And then even if the rule is grammatically correct, performance can be off the charts bad, and still the rule looks fine. Do you have any clues in here that, I know it does a great job on getting the syntax and the grammar correct. Do you have any indicators or warnings about performance?
Yeah, so the Suricata engine analysis has some indication about the performance of the rule. So there is a few tips that are about the performance of the rule that will not prevent you to write a bad rule, but that will, at least in some case, we will warn you about a possible issue. So this comes back in the interface. And in the new release of Suricata language server that has been done today, the 0.9, we have a new feature that is fast pattern checking. So fast pattern is something that is used in Suricata to optimize the evaluation of signatures. And the concept of fast pattern is to pre-filter everything in one pass and then just evaluate a few signatures that match this fast pattern. But if you have 1,000 signatures that are using the same fast pattern, then you have a problem. because you will have 1,000 evaluation of the signature, so it will be slow. So in this new version, it covers multiple files. It analyzes all the files in the current directory, get all the fast pattern, and then told you if you're writing, even if you write a new file, but this fast pattern had already been used 20 times in some other files, so you know that you should not use this fast pattern. So that's one thing to improve the performances. It's not perfect, and it will not replace running this on PCAP. Maybe that's something we can do, but it looks a little bit bizarre with the Suricata language server to do that.
Okay. So I realize you probably, as many of us that start an open source project, you're writing something to solve a problem you have. And as a professional signature writer and coder on Suri, definitely this is what you need. Where does the average guy defending the local bank that probably doesn't write rules very often, but I would argue ought to be able to do so in a pinch? Is this a tool that person's going to want to spend the time setting up and use and learn?
So if you take one of the easiest samples, which is Visual Studio Code, the installation is something like, I download Suricata executable. If you're on Windows, you install the package, and then you install the server itself. And so in 5 minutes, you're done.
Okay.
And then you can, maybe you experiment a little bit, or you want to read, even it can be useful if you want to ingest some threat intel and want to check them before. You open them before, check if there is some performance issue that are given by Suricata language server. And then you can try to tune them or just command them if you think they can be an issue.
Yeah. And I kind of asked a leading question there because I have an opinion on that. Definitely. I think everybody that defends a company or defends anything important should know how to write some rules and how to avoid at least the basic performance flaws, because you have something that looks funny. You wonder, gee, I wonder if that ever happens again, or has it happened in the past, or is it going to happen in the future? If you can write yourself a quick rule and watch it for a week, that is far more informative than trying to data mine your history on looking for something that may not have been detected because there's no rule for it. So being able to write your own rule is highly critical, as well as the data mining. So this is an incredible tool for that. And again, we have time for questions, a few yet, if you have any, and we have one more project though, so I think we need to move a little quickly there. So Eric, thank you very much. Did you have anything last you wanted to say about the project? I don't think so. So let's move on to Marcus again with GopherCap. I think with GopherCap definitely wins the award for the largest amount of data you can put into a project will definitely be GopherCap. So Marcus, please.
Hello again. So story time. Once upon a time in Stamus, we had some PCAPs. Those PCAPs were on a disk. We thought, well, they are on a disk. Why are they on a disk? Why aren't we replaying them? Well, okay, let's replay. Peter had an idea. Hey, let's just loop over with TCP replay. 3 days later, our sysadmin came to us in a chat saying the replay is still running, and I think it's gone through only about 10% of the PCAP files. And we were a little bit puzzled at that point because there was only 2 days worth of data there. So that was a little bit confusing. But I quickly realized that why this happened was because PCAPs were written using this tool called Archive. Then it was called Moloch. And Moloch has workers. And session reconstruction 101, all packets of the same session have to go to the same worker. And each worker wrote to its own PCAP file. And each worker also rotated those PCAP files when the PCAP file became full. So 12 gigabytes of data, next PCAP. So in reality, the replay was kind of assuming there to be a continuous stream of PCAP files. One is done, go to the next, go to the next, go to the next. In reality, there were actually n number of PCAP sets and we had no idea which is which. Where did one PCAP end and the other one begin? So then I got an idea, because what I did was I wrote Gopher to deal with that specific problem. So Golang, I really like Golang. It's one of my favorite languages to write code in, and Golang has very nice concurrency. You can spin up a lot of workers. So what we just did was we spin up, basically we replay all of the PCAPs all at once. We simply map them first, and each worker waits until it's his time to replay. And that kind of solved the problem. And then we started thinking, well, I started thinking like, that's like a terabyte of PCAP on the disk. Like, why do we need to keep it uncompressed? Like, couldn't I just like read it directly from a gzip handle? Oh, there's a tarball of PCAPs. Like, I actually only want a couple of those. I don't want to unpack the whole tarball just to get like 2 PCAPs. Oh, wait, replay is running for 2 days, but that attack happened on the day 2. So I don't want to wait 2 days for that attack to actually come in the replay. Couldn't we speed it up somehow? And then things like that started getting into it. In reality, Gopher was actually an evolvement of a bunch of throwaway tools I've written to do these kinds of things, but I decided it's time to actually make a real tool and give it out kind of to motivate, because maybe other people also have these kinds of problems. Another problem that and it's basically it's a command line tool that implements a bunch of subcommands. We are pretty friendly with like the implementation of the subcommands, because we know that people using this tool probably aren't going to be maybe like they can write code, but they might not be like full-time developers. So this is very much aimed towards data engineers, threat researchers, rule writers, technically sound, but I'm not gonna like we're not gonna torture them with like very lengthy reviews. Like, can you reformat this, that, and that? In fact, Eric implemented one subcommand for packet filtering as a project for learning code. And that subcommand is even used right now in our commercial product for the conditional PCAP extractions. Hey, I have this event. I have Suricata actually wrote a PCAP file for all of the packets in the alert. Now we would like to be able to extract it. Well, we have a subcommand it, and over time added additional features, something like being able to actually decapsulate packets, because some PCAP files we have are encapsulated in ER-span and GRE tunnels. Then you try to filter on top of it, and none of the filters work. Why? Because the exterior packet is actually the tunnel, and you want to go 2 layers deep, but not too deep, because then you might end up all the way in the fun world of stuff like a Docker Swarm, VXLAN packets, where then you've gone too far, and you actually get the private layer inside the Docker VLAN when you actually want one level up, but not the one at the very top. So things like that. Long story short, it's a command line tool to deal with very niche, but otherwise very, very tricky to deal with situations when working with either large PCAPs. If you want to do something really specific and you discover that your tools just don't handle it that well, things like that. And the idea was always also to kind of of course, I wrote a blog series about it, going very in depth about how I built it, because it uses something called GoPacket from Google, which is a very powerful packet processing library. And the idea was always to motivate the community, or to also bring in contributions, or at least give their ideas of these kinds of tricky PCAP processing scenarios that regular tools just don't handle that well.
It's a fascinating project. I'm only offended that you waited till after I retired to put it together, because back in the emerging threats days, we spent a lot of money building something that wasn't half as good as this. So It's a very effective tool that a lot of people should be using, whether you're just writing your own or you're doing this commercially. Is there, Marcus, do you think, we're a little short on time, so I have to keep it to a minimum question with you, but I'm very curious for hardware, for somebody that's not looking to process terabytes, we're just talking, 10, 20, maybe 100 gig of PCAPs that I want to run, and it's not real important to be super fast. Do I need any overkill on hardware, or is just your regular server you got sitting on the wayside going to be fine?
For this guy, I'm actually regularly running it just on my PC.
Okay, so it's
a very light Go tool. The only build dependency is lead PCAP because replay has to write packets back into the interface. But it is very lightweight. It is running in our QA lab probes. For me, I like to replay all MTA PCAPs all at the same time for maximum noise there. And those are VMs that have something like 8 gigs, where I would say 90%, I think the probe even has less, like 2 gigs of RAM, and most of it is already in use and only 2 threads. So it's
so we don't
not heavy.
We don't have to set up an ISO-LAN and
no
CPU somewhere. Okay, very good to know. I appreciate that, and it's great. Like I said, it's a great project. Very, very valuable, especially if you're writing rules. But even if you're just tuning your own rule sets and you have some high-speed links that you need to make sure that rule set is tuned well for, this is the kind of tool you need to get there. So, but unfortunately, we are short on time. So let me say, first off, thank you to all our presenters. These projects are awesome, and I know you guys don't get thanked enough for making an open source project. So thank you for making those things. It is appreciated by all of us that are using them. And with that, let me turn it back over to Kim to do some housekeeping, and there's a poll and some very interesting things, but thank you for your time.
So I'm going to go ahead and launch a poll. And when I do that, I'm also going to ask a question that I do have in the Q&A. So if folks want to take a look at that or answer that. So I'm going to go ahead and launch the poll. You should be able to see that on your screen right now. So it's just a quick question about, all of the tools that we've talked about. Are there any in particular that you'd really want to see a little bit more in-depth webinar about, which would be, it's helpful for us to kind of see what your interests are on the audience, and keep your eye out for new webinars, of course. All right, so I did have another question that came in. This was about SELCs. So George is asking, is there a procedure or set of guidelines to help integrate other Docker containers into SELCs? So whoever would like to take that.
I can take that. Yeah, that's a very good point. On the technical side, I don't think we have anything specifically documented. This is the steps you need to follow. It's basically a Docker Compose. So if you'd like to plug in another Docker Compose container in there, it's pretty straightforward. It does remind me, though, this is a great feature request for our documentation to actually explain or give a small example of how to do it. And we'll probably do that after the webinar. But basically, it's adding, let's say, another Docker to the Docker Compose configuration there. And we'll add that to the docs, no problem.
Okay, excellent. All right, I'm going to go ahead and end the poll. So you guys can, if anyone's interested in the results, you can take a look at that. I did get one other question, so I'll take one more. We are a few minutes after, so I don't want to go too much longer, but another question asking about documentation that can help with Suricata integration in Kubernetes. Hopefully I'm saying that correctly.
I can take it. There is multiple sense in the question. One, since if you try to capture the traffic, I don't know really well the documentation for that. I know that we have a pull request that is using Suricata in Kubernetes to sniff the traffic, that is an evolution of SELCs. But we got a merge request on GitHub for that. But if the question is about integrating Suricata in one existing the Kubernetes container, I don't have answer. I don't have an answer. Sorry.
Okay, great, no problem. All right, so I think that is it. We're pretty much out of time and Q&A. The one thing I did want to mention, I talked about this at the beginning of the webinar. So if you registered and you provided us with your full address, you will be receiving a hard copy of the book. It will be a couple of weeks. Orders for those will go in today, and then those will be shipped directly out to you. If for some reason you registered, you are on the call, and you didn't give me your address, you can feel free to send an email to me. It's Kim, K-I-M, at stamus-networks.com, and I'll get that out to you. But the good news is you can actually download a copy of that today, and you have a link there on your screen. You can also go to our website and get to that as well. All right, and we do have some other resources here. If you need some more information on Stamus Labs and some of the tools that we talked about today, you can go ahead to our website and go to Stamus Labs and get more information on those. And then we also have a resource library that has lots of information, all of our white papers, videos, tech briefs, data sheets. You can find that information online as well. All right, great. I think that just about wraps it up. Thank you again, everyone, all our attendees for joining us. And thank you, Matt, so much for being with us. It was excellent. And to all of our panelists.